Okay, here is first time interference. Interference in optics is very important topic, and that explains the how the light waves travel. So here is, that this is about explanation of light waves and when strike in any screen, how they look. And somewhere you can see the dark band, somewhere you can see the bright band, and where are the dark band and where are the bright band. That's our main aim. So the one of the scientists whose name was Young, so he first did experiment and kept the experiment which we call the Young's double slit experiment. In this experiment, whatever things are set up, how they were set up here is given all these things. You can see AB are the slit as a source, and from this source a light is coming here from A slit and B slit. The light is going to inside in between the slit and the screen and stuck at point P. You can see that capital D is distance between them, and the small d is the what is the distance between two slits. In here is given the explanation is about this whole experiment of this Young's double slit. You can see, let us consider as be the source of a monochromatic light, and A and B are the two slit which are act as a coherent source, and D is small d is the distance between A and B. And let's say screen XY, you can see the screen XY is placed to D distance away from the source. Here is from this slit, and which is equal distance from the A and B. You can see here the center point is C, which is equal distance from A and B, same as here. The C is in between A and B. And let's P be the point x distance from the C. The from the C, P is x distance above. And where AB and BP rays of a light meet each other, that means at point P, from the A slit and from the B slit, two waves come out and meet at this point, where you can see the difference, part difference in between them. तपाईले यो दुईटाको बीचमा पार्ट डिफरेन्स देख्न सक्नुहुन्छ. अब A र B यहाँ A र P छ अनि B र P छ भनेपछि यो र यति बाटो सँगै हिँड्यो, यति बाटो चाहिँ अलि बढी हिँडेको छ BP वेभले. सो द कति बाटोमा भएको डिफरेन्स कति छ त BP minus AP, and the formula is BP minus AP, you can see here. And where BP square को फर्मुला लगाउने भने अब यो ट्रायंगलमा ट्रायंगल BP क्यू ट्रायंगलमा पाइथागोरस थ्योरम लगाउने तपाई BP स्क्वायर यो आउँछ h स्क्वायर इक्वल टु p स्क्वायर प्लस b स्क्वायर formula. When you apply here in case of BPQ, you get this expression. Same the way AP you can get applying Pythagoras theorem in the triangle APR. You can get this one. When you subtract BP minus AP, that means AP when gets subtracted from the BP, when AP gets subtracted, then you can get this one, because the BP square is here is BP square's value you can see here, and AP square's value you can see here, and whatever value from here you substitute at this point, and d square cancel each other, and whatever remaining part here is, and calculate this. You get 2xd when you open this formula in the a plus b a minus b formula. Same the way open this one, and a minus b is as it is here, a plus b in this side, and here a BP and AP. The when this P point reaches to the C, then A C and BP, that means it is 2 points A BP and AP gonna go equal. So that here we consider if the point P lies at very near to the point C, then AP nearly equal to BP equal to capital D. When we add this one would be D, or this again this one would be D. When they get added, then we get 2D, and 2 cancel each other, then the part difference we get x d by capital D. And the same the way phase difference we have formula 2 by lambda into part difference is x d. When we put here a value of a part difference, we get the phase difference too. The where at which point when we allow the light incident on the screen, at which point of a screen we have a dark fringe, we can get here dark fringe. Here you can see at the central part मा ब्राइट फ्रिन्ज आयो, सेतो धब्बा देखिरहेछ भनेपछि त्यसपछि कालो सेतो कालो हुँदै गएर यहाँ ब्राइट र डार्क फ्रिन्जहरु देखिरहेछ, ब्यान्डहरु. भनेपछि अब ब्राइट फ्रिन्ज कुन केसमा, इन व्हाट केसेस That means in what position we can get bright fringe and in what cases we can get dark fringe. That's our main aim. र constructive interference भयो भने चाहिँ dark bright fringe हरु बन्छ अनि bright fringe कुन कुन पोइन्टमा बन्छ त जुन पोइन्टमा पार्ट डिफरेन्स n lambda हुन्छ त्यो पोइन्टमा यहाँ चाहिँ ब्राइट फ्रिन्जहरु बन्छ n lambda भनेको चाहिँ यो चाहिँ पार्ट डिफरेन्स n lambda एज इट इज छ पार्ट डिफरेन्स x d by d यहाँबाट ल्याएको पार्ट डिफरेन्स राख्यो भने x बराबर n lambda d by क्यापिटल स्मल d छ यो पोइन्टले x भनेको यो पोजिसनमा यदि n को भ्यालु भनेको चाहिँ 1 2 0 देखि 1 2 3 सम्म हुन्छ अब यसको भ्यालु चाहिँ यदि कुन पोजिसनमा कति टाढा भन्दाखेरि c मा चाहिँ ब्राइट डिफरेन्स बन्यो ब्राइट फ्रिन्ज बन्यो भने अर्को माथि कहाँ बन्छ त भनेर पोजिसन थाहा पाउनलाई यो फर्मुला युज गर्छौं त्यसै गरेर डार्क फ्रिन्ज अब यो भन्दा माथि डार्क फ्रिन्ज कुन कुन पोइन्टमा इन which points are being given the dark fringe of a light we can get with the help of part difference equal to 2n plus 1 by 2 lambda and you know the part difference is x d by d from here when we compare x equal to 2n plus 1 divided by 2 lambda capital D divided by small d is the position you know the x represents the position at this position on the screen you can get to see what you see the dark fringe or destructive interference wherever dark fringe you can see these are the destructive interference where you can see the bright fringe they are the constructive interference so most important thing you should remember here is part difference n lambda is for a constructive interference or to get bright fringe and path difference should be equal to 2n plus 1 by 2 into lambda for the dark fringes to be seen on a screen XY. That's why this Young's double slit experiment proves that the different fringes that can appear when the light from the slit strike on the screen. And similarly, you can see the fringe width means how the width of how much width of this fringe bright fringe को width भनेको चाहिँ चौडाइ कति ठुलो छ त भनेर थाहा पाउनलाई बीटा it is represented by b equal to x2 minus x1 when you apply in this to any whether you apply in this formula or whether you apply in this formula you get the value of x2 because you put n equal to 2 and here you put n equal to 1 value when you subtract x2 minus x1 then you can find x capital D lambda capital D divided by small d and this is the fringe यति चौडा भएको चाहिँ ब्यान्डहरु भन्छ यसको ब्यान्ड भनेको चाहिँ डार्क ब्यान्ड कालो धब्बाको पनि र सेतो धब्बाको दुईटैको सेम चाहिँ विड्थ हुन्छ र यहाँ चाहिँ you can see the distribution intensity distribution of the interference here everywhere you can see the its fringe width equal you know the pi everywhere you can see the same width is given so that fringe width of the bright fringe or of the dark fringe they all are equal they are all fringe width equal we can see there that is all about this our Young's double slit experiment. Do not forget when anybody asks you what is double slit experiment to say about this one screen and two slit one source and from these two slit two light are going to strike on a point on a screen and where we can see different band that might be dark band that might be a bright band and where are the dark band where are the bright band we can get with the help of these two formula x equal to n lambda because these two give us the position of the dark band on a screen that's why we need this experiment thank you